The winter is officially over in Melbourne, but the weather didn't seem to have noticed that in the past weeks. People are dropping like flies with sick leave, from a cold, the flu, achoo, or worst of all, COVID. This means... But does vitamin C really help against cold and flu? Not always. If you could really benefit from extra doses of vitamin C, or if you might as well leave it be, we'll science check that now. Hello there, my science friends, and welcome back to Shelium. It's me again, Susie, your friendly neighborhood chemist. And this is Linus Pauling, a much bigger friendly neighborhood chemist. He's got not only one, but 2 Nobel Prizes. 1954 in chemistry and 1962 the Nobel Peace Prize for his activism against nuclear weapon tests. In 1970 he published a book with the title Vitamin C and the Common Cold, as he was convinced vitamin C helps against cold and flu. Just about as convinced as many of us are today, as he basically started the whole vitamin C hype that lasts until today. Okay, so usually the daily need of vitamin C is around 90 to 110 milligram, as vitamin C is important, for example for certain metabolic processes, and it's also an antioxidant. Here in Australia, nobody has a lack of vitamin C. Nonetheless, you can buy tons of vitamin C supplements at any chemist or supermarket. They are even advertised as cold relief, with doses of 200 milligrams and more. Mostly more than that, because more is better against colds. Linus Pauling already said that. But even your friendly neighborhood chemists are not always right. Even chemists can be mistaken. Or rather, the science can be mistaken, as particularly medical correlations are often so complex that it takes a lot of studies and a lot of results to get a clear picture. And exactly because medical studies are often so complex, the Cochrane collaboration exists, an international independent network of scientists and medics. They look at a lot of different studies from one topic and compare them, rate them against each other, and summarize them. Most often they publish so-called review papers. A review is basically a study about studies. And look, there is a Cochrane review about vitamin C and its role during a cold. And it is very interesting. To only get reliable data, the review looked exclusively at so-called controlled studies. But what does that mean? Imagine you are a scientist and you want to test if vitamin C helps against colds. It's not enough to give people vitamin C tablets and look if they're feeling better. Because no matter what's in the tablet, the expectation I should feel better by taking this tablet alone can lead to me actually feeling better. Placebo effect. That's why we need a control group, so a second test group that only gets placebo pills with no vitamin C in them. And only if your test group with vitamin C feels significantly better than your control group with the placebo pill, only then vitamin C works. Remember, if you want impactful and significant studies, you need controlled studies. So, there are quite a few controlled studies that researched if vitamin C prevents colds. To be exact, if a daily high dose of vitamin C lowers the risk of getting a cold. In this review, 29 studies were summarized with overall over 11,000 participants. That's a lot, so statistically, that's awesome. However, unfortunately, we can't just sum up all the results of those 29 studies, divide them by 29, and that's it. Because a study with a low number of participants and a high statistic deviation has a lot less value than a study with a high number of participants and a low statistic deviation. Or maybe one study only looked at a group of participants that is hard to compare to the participants of other studies. That's why a so-called meta-analysis is needed, in which you weigh up and assess the results from each study against each other reasonably. A common tool for analyses like that is the so-called forest plot, sometimes also called blobogram. Let's say we create a meta-analysis of 5 different studies. Every study has researched if the risk of a cold decreases when taking vitamin C. 1 is our reference value. Let's say in study 1 was observed that the risk decreases by half, then the result is 0.5. In study 2, the result was more or less the same, so we're at 1. Study 3 measured a doubled risk, so 2, and so on. Now every study here is only represented by an average value. Would we repeat the same study with a few different participants, the average value would be a little bit further left or right. This is why for every study a so-called confidence interval is calculated. Instead of a point value, I now have a bar. The smaller the confidence interval, the more I can trust the average value. So the shorter this bar, the more accurate is my point. So we shouldn't really look at the distribution of the average points around the reference line, but how the bars are distributed. To make this even more obvious, the points with less significance are plotted smaller and the ones with more significance and meaning bigger. Accordingly, these points need to be weighed differently so you come to an overall result in the end. The same was done with those 29 studies to get this forest plot. Don't let those arrows throw you off. An arrow is basically a visual shortcut when the arrow bar doesn't have enough space to one side. Then you just have to imagine the other half symmetrically to the rest. If you summarize all those studies, vitamin C reduces the risk of getting a cold by just about 0 to 6%. However, 5 studies were not included in this result, which are listed extra in this review. In those 5 studies, they didn't just look at any participant from the broad public, but at specific groups that are hard to compare, which were marathon runners, cross-country skiers, and Canadian soldiers on a subarctic mission. In those groups, with acute high physical stress, vitamin C led to a significant decrease in the risk of catching a cold. All in all, a decrease of 36 to 65%. Well, the skiers and the soldiers were only 1 study each, but the marathon runners were at least 3 studies. So, to my marathon running friends. Anyway, if you're not a marathon runner, vitamin C won't help you catch a cold less often. But if you have a cold, it won't last as long. That's what they found in a different meta-analysis. In adults, the duration of a cold was shortened by 8%, and in children by even 14%. Let's summarize. A lot of vitamin C doesn't help you lower the risk of catching a cold, except you are a marathon runner, and maybe also a cross-country skier and a soldier in the subarctic. But the duration of a cold can be shortened. Also, none of the studies found a negative side effect of high doses of vitamin C. So if you know any vitamin C junkies, send them this video. Now I want to know about you. Do you take regular vitamin C tablets or any other supplements? And if so, which ones? Let me know in the comments below with the hashtag subs. And feel free to use it to ask me questions about specific ones, so maybe I can make a video on them in the future. I see you in my next video. Until then, stay sciencey.